Alright, so in this video I want to talk about the mixture of expert, which is actually the Mistral model. So let's talk about this. So this is the diagram which I introduced in the starting of this playlist series, and where we can see like the input goes through an embedding layer, then the embedding gets generated, which then gets normalized with RMS norm, and then we add the rotary positional encodings to the query and key matrices, and the V is kept as it is. Then we kind of do the certain tasks which are related to the attention mechanism, like sliding window attention, grouped query attention. Then there is a rolling buffer KB cache. So all this I have discussed in this playlist, and the only thing that is being left is the mixture of experts part, right? So here we can see that this is our mixture of expert, which is nothing but a feed forward network. So there are actually 8 into 7 billion models are there. So there are 7 billion models which are nothing but a feed forward network layer which is present here. And before going to the feed forward network, we have a gating mechanism here. So don't worry about each of these terms. This is just that the new things which we will discuss in this video, I am adding it to the diagram, and we will discuss what this gating mechanism is and what is this MoE. And also here we kind of, once we get the output, we take a weighted uh, sum or average. So this is actually a weighted sum or average, and then we kind of produce the output, which again goes through RMS layer, then it goes through a linear layer, which kind of produces the logits for each of the tokens in the vocabulary. Then we take the softmax to select the particular token which is related to the input, right? So this is kind of a high level architecture of the whole mixture of experts, and I have kind of discussed each of these components in detail in this playlist. And if you want to understand the mixture of experts, so this is the video where you should look. Now let's talk about what this mixture of expert is, right? So we have our input. This input goes through a gating layer. So this in between we like kind of do those extra stuff which are related to attention mechanism, like sliding window attention, the grouped query attention. Then there is a KB cache with rolling buffer. So all this we do, then we pass it through a gating layer. So this gate layer actually kind of selects the 2 out of this 8 experts, right? So in fact this gating layer is kind of a feed forward network which kind of generates the logit, and based on those logit values it selects the most probable 2 experts for each token, right? So that is quite important. For each token the 2 experts are getting selected. So at first, like based on the logit score, the expert 3 is selected, and also expert 7 is selected. So this is just an illustrative purpose. I am showing that 2 experts are selected out of the 8 experts that are present here, and each of these experts are nothing but a feed forward network that is part of the feed forward network in that whole Mistral architecture, right? So once that is done, and what we do is, using those logit score which are being produced by the gating mechanism here, we kind of use a softmax to get the weights. So once we get the weights, what we do is we calculate the weighted sum or average using those weights, and we produce the outputs. So if I just try to explain with like what this logit and weights mechanisms are. So for each of this expert, this gate kind of produces a logit value. So just for illustrative purpose, I'm taking the random values, like this is 1.3, this is like 1.01, so this is like 1.99, and similarly we have like other random values. So I'm just taking, and also for this we are saying that this is 1.90, right? So we can see like the highest values are this 1.90 and 1.99. So based on that it will select this expert 3 and expert 7, and using this logits then we will apply a softmax here to produce the weights. So these weights will be normalized values, and that normalized values will be in the range of 0 to 1. So for an example, like this is kind of the highest weight, so that is being produced here. So say for an example, say like this is like 0.60, and this is like 0.40. This is again randomly I'm using this weights. Actually these two values will be used, and these two values will be softmax to get this weights, right? So once we produce this weights, so using those weights for every token we kind of create a weighted sum or average, and then we produce the output. So this is actually the high level overview of what the mixture of experts look and how the data flows through this Mixtral architecture of this mixture of experts. Right now the question comes, why we are saying this as sparse mixture of experts, right? So as you can see here, we have like 8 experts, but we are only selecting 2 experts out of these 8 experts. So it's not that all the 8 experts are being used to calculate the weighted sum or average then produce the output. Only 2 of them is selected. That's why we are saying that this is a sparse mixture of experts. So if we are selecting all the experts, then we will not say that this is a sparse mixture of experts. So that's why we kind of use this term and we call it as sparse mixture of experts. Right now let's talk about few of the details of this architecture. So first of all, like each experts, which is a 7 billion model, is trained on a subset of data so that each expert is specialized on a certain task, right? Then this gating layer, which I have shown in the last slide, right? So this gating layer is a linear layer which was trained along with the experts and also with the rest of the models. So it's not that this gating layer was trained in a separate process. So it is part of the whole training process and it is being trained with along with the experts and the rest of the model, right? And each input tokens embeddings, so once the input comes, the gating layer produces kind of 8 logits for each individual experts, which is being used to select 2 experts with the highest logit values, right? So which I also explained in the last slide, that the gating layer will produce the 8 logit values which is corresponding to each of the experts, and which two the highest 2 logit values will be selected, and those 2 experts will be selected. Then the input will go pass through those experts, and then we will use a softmax to kind of normalize those 2 logit values only to get a weights out of those logits using a softmax, and then we kind of do a weighted sum or average, and we get the we produce the outputs using that, right? So then this sparse mixture of experts allow us to increase the parameters of the model, right? So we can see like here 8 experts are present, with each of them are 7 billion models, right? So we kind of increase the model parameters, and it has been seen that in case of large language model, the more parameters you have, and the better the performance is, right? So that we have seen in case of the progression of like GPT-1, GPT-2 and GPT-3.5 and the GPT-4, right? So every time the model parameters got increased by huge margins, and the model performance also got a boost with that. So that they have also tried to use that in the mixture of experts or the Mistral model, but the computation or inference time is kind of remained same, right? So because we are only using 2 experts out of those 8 experts, and then we are doing the intermediate steps or the matrix multiplications, so that the inference time is kind of same across this whole increased experts and the model parameters, right? So this is and we can see like this is from the current paper like which got recently published, that Mixtral 8x7b instruct model is kind of the best open source model that is available currently, and it also kind of beats the GPT 3.5 turbo, right? So we can see like Mixtral is present here, and it is kind of beating the GPT 3.5 turbo model, right? And it also comes with a license of Apache 2.0, which is kind of a open weight model, so you can go ahead and use these weights for your commercial purposes. So what we can see is this is kind of the best open source model, which is just below the GPT-4 models and the Claude 1 and Claude 2.0 models, right? So very much in detail. So attention is all you need is kind of stood the test of time. But if you want to go one step further, this is the Mistral is the model which whose architecture you can study and understand, so that the changes that has been brought into the attention is all you need mechanism that you can understand, and you can like get a grasp of this whole concept. right? So with this, so thank you, thanks for your time and showing support for this whole series. Thank you. See you in the next video.